ABS, the magic that prevents skidding and saves lives in your car. Hey, engineering moms! Today we're going to uncover a technology without which many accidents would have had a very different outcome. Have you ever found yourself in an emergency situation where you had to slam on the brakes and the car simply obeyed, stopping in a straight line without skidding out of control? Well, that magic isn't really magic. It's pure engineering and it has a name, ABS, the anti-lock braking system. But what exactly is ABS and why is it so crucial for safety? To understand that, we need to go back a bit and think about how conventional brakes used to work and what their major problems were. Imagine you're driving and suddenly need to brake hard. What's your first reaction? Slam your foot on the brake pedal, right? In a car without ABS, that action would almost always lead to the wheels locking up, especially on slippery surfaces. When the wheels lock up, the car loses traction and consequently steering control. You try to turn the steering wheel, but the car keeps going straight, sliding without stopping. It was exactly to solve this critical problem that ABS was developed. But how can a system prevent the wheels from locking up, keeping control of the vehicle even during emergency braking? The secret lies in a super fast dance between sensors and the car's electronic control unit. ABS doesn't allow the wheels to lock up because it modulates the brake pressure on each wheel individually thousands of times per second. But how does the car know that a wheel is about to lock up? That's where the speed sensors come in. Each wheel of your car has a small sensor that constantly monitors its rotation. During hard braking, if the rotation of one wheel decreases much faster than the others, or gets close to zero, while the vehicle is still moving, the system understands that this wheel is about to lock up. As soon as a sensor detects this condition, it sends a signal to the electronic control unit, the ABS ECU, which is the brain of the system. And what does this brain do when it receives this information? The ABS ECU then goes into action. It doesn't just release the brake. It performs a cycle of releasing and applying brake pressure to that specific wheel extremely quickly. Think of it like you're pumping the brake pedal manually, only thousands of times faster. Algo impossível. It's done through hydraulic valves, which can decrease, maintain, or increase the brake fluid pressure in the calipers of each wheel. This process prevents the wheel from locking up completely, allowing it to keep spinning, even if slowly. But why is it so important for the wheels to keep spinning a little? What's the advantage of a wheel that's spinning instead of locked? The big point is that for you to be able to turn the steering wheel and steer the car, the wheels need to be spinning. A locked wheel is like a ski on snow. It just slides in the direction the car is going. By modulating the pressure and preventing locking, ABS ensures that the wheels maintain a certain level of grip on the road. This allows you to maintain steering control and, crucially, to swerve around an obstacle even during emergency braking. The ability to steer and brake at the same time is what makes ABS a game changer in vehicle safety. You may have felt the brake pedal vibrate or heard a strange noise during hard braking with ABS. That's normal and it's the system working. It's a sign that the valves are rapidly modulating the pressure and the sensors are doing their job. Many people get scared by this sensation and even let go of the brake. But the right thing to do is to keep firm pressure on the pedal so the system keeps working. The history of ABS is fascinating. Although the idea of an anti-lock system has existed since the beginning of the 20th century, from the 1970s onward, the technology started to become viable for passenger cars, driven by advances in electronics. Manufacturers like Bosch played a fundamental role in the development and popularization of the system. Initially, it was a luxury item, but its effectiveness in reducing accidents made it a standard safety feature and, in many countries, even mandatory. But what are those other systems we hear about, like traction control and stability control? Are they related to ABS? Yes, ABS is the foundation for many other safety systems. Traction control, TCS or ASR, for example, uses the same wheel sensors as ABS to prevent the wheels from slipping during acceleration. If one wheel starts spinning faster than the others, TCS reduces engine power or applies the brake to that wheel so it can regain traction. Electronic stability control, ESC or ESP, is even more sophisticated. It uses information from ABS sensors, as well as other sensors that measure the vehicle's rotation and the steering wheel position, to detect if the car is about to lose control in curves or sudden swerves. If the car starts to skid with understeer or oversteer, the ESP applies the brake to specific wheels to correct the trajectory and bring the vehicle back under control. In other words, ABS is not just a braking system, but the backbone of an entire set of active safety technologies. It's important to point out that although ABS is an amazing system, it doesn't work miracles. It helps maintain directional control and reduce braking distance in some conditions, but it doesn't defy the laws of physics. If you're going too fast in a tight curve or on a surface with very little grip, physics will still prevail. It's a tool to assist the driver in critical situations, not a license to drive like Brian out there. Brake, tire, and suspension maintenance are still fundamental for the overall safety of the vehicle. So the next time you step on your car's brake and feel that sense of control, remember, it's not magic. It's the result of a lot of engineering and technology working silently to ensure everyone's safety on the road. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like and hit the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or click the link in the video description to access several opportunities to develop various skills that will make a difference in your career. And what about you? Have you ever felt the ABS kick in during an emergency? Or maybe you have a story to share about how it helped you. Drop it in the comments because I want to know. Over here, there are 2 interesting videos you need to watch to broaden your knowledge and satisfy your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.